All right, we're streaming. So we've got problems, and at the moment, I literally have no idea, none whatsoever, how to solve them. I think it's important to realize that we have figured out how to change this font size in a nice way. Uh-oh. Okay, I got a message from my daughter's daycare. I was worried it was a problem. It's not. Everything's okay. Well, if I don't some way to figure this out soon, this is going to be a real short stream. Ooh. What's the size? Okay, not. Oh. Oh, 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 oh. Okay. Too many arguments to log. Okay, so this is what we're setting as the initial values. I think there's something wrong here. There's something wrong here. You see these stripes right here? Well, that shouldn't be. This is me just trying to use the nearest value. Okay, so this is the data, and you see that there's every other column is missing, right? And then this is K naught. I'm going to reduce the amount that I'm scaling these things. This is K data with the initial values of K naught put in to the missing locations, to the locations that we need to estimate. Okay. And this is the original data. I've been reading books by David Gran, I think is the name. This book is fantastic. This book is excellent. This book is absolutely amazing. I haven't read this one. I'm reading this one right now. I didn't know about this one. What is that? I'm sure this is going to be great, and I'm going to put it onto the shopping list here. Anyways, as I was saying, this book is really fun. That's the one I'm reading right now. It's lots of, each chapter is its own story. Now, I just remembered that I was interested in learning about that. It's a $220 book. Wow. Well, I'll have to think about that later. Okay, so here we are. We've got now what I tried to do. Oh my gosh. Wait, no, that's right. Okay. What I tried to do is take the nearest values, right? And you could see that the stripes are showing up. I'm gonna have to zoom into one of these. Okay, so my goodness. 326, 121. It's 326 minus 255, 71. We don't need exact numbers, just roughly. Okay, so in the second coil, 71 horizontal, 125 or so vertical. Look at the stripes of coil 2. And I'm going to look at the same thing of the data. Huh. Huh. Okay, so this perfectly illustrates what I was trying to say. So this is with the initial guess, and this is the original data. So all the black pieces here need to be um, replaced by the initial guess. And the initial guess is just supposed to, for example, this point here should either be that value or it should be that value, none other. And yet it's darker than both of them. So this tells me, at least with the initial guess, that there's a problem. What is that problem? I think it's indexed to sub. Row, column. Row, column. I don't like doing this, but I'm just going to see what happens if I reverse those two. That certainly didn't fix it, and that didn't help. Okay. I think this is right. Oh. Oh no, I'm just looking at one coil of the one slice of the sample mask. Okay. So this could be outside of the coil loop. If you can't fix problems, at least you can make it ever so slightly, negligibly, unnoticeably more efficient. That always makes things better. Oh, this can also be outside of the loop. And that's the issue right there. We needed the K. We're not interpolating the K data with data indices. We're interpolating into the K data of this coil with data indices. I'll bet you that fixes it. Yep. These are twice as wide now because we're doing nearest neighbor interpolation. Okay, so we at least fixed something today. But not nearly enough. I didn't actually expect this to improve the quality of the image because LSQR, if it converges, and it is, should converge regardless of what the initial value is. The idea here was just to get it to converge quicker. Let's take a look at the Fourier values of k out. Presumably, we'll still have the stripes there because we still, of course, have we still have the aliasing. This aliasing. It's like the high frequencies are shifted. It's like if we were able to shift the high frequencies by half the field of view and add it to the low frequencies, we would have a good quality image out. And just in the horizontal direction, well, that'll drive you nuts. Like vertically, there isn't any aliasing. There's only aliasing in the horizontal direction. Boy, oh boy. Before I forget, let's check in this fix. Okay. Right, the stripes are just horizontal. Oh, but of course they are. Because vertically, we are fully sampled. If I change the if I change the sampling pattern to be undersampled vertically instead of horizontally, I'll bet you I'm going to get aliasing vertically now, but not horizontally. Yeah. And like I say, it seems like I just want to shift the high frequencies by half the field of view. Okay, that's tough. It's like K star has an origin different than K out. Said differently, it's like K star has an origin at a different location than K data. Let's make sure these things are still working. They still pass. I think the problem's going to be with either apply A or apply W. I think there's an FFT shift missing, or there's one added that shouldn't be there. Cert com 2 assumes that the origin is in the middle. Does this need to be inside this function, or can it be outside of it? Seems like it could be outside of it. Then we don't have to reallocate that data all the time. So this K estimate is not the same as this. This is this. Once we get at this point, at 68, K estimate is actually this. Maybe I could call it like K estimate matrix or something. I don't know why I put an underscore here. In is K estimate. In is this. This is because I transpose is equal to U transpose minus I. I don't see the issue with apply A. How about apply W? How about just W? Here's finding W. Ah. Do you guys remember that I had to do this shift here in circular convolution 1 because I was putting the origin of the output at the first element? I wonder if a similar thing is happening here. Doesn't seem like it is, does it? And I guess we checked that with this test. Oh boy. If I wasn't streaming, this would be a good time to get help from somebody else. And by help, I mean just talking it through with somebody. What was the issue we solved here? All right, this. We don't actually need to store key data coil. This is weird. There's two spaces here, but there's only, if I go down, I'm only one space away from the column. I need a font that's like evenly spaced per character. That font evenly spaced per character. Fixed width font, that's what I meant. You can specify this by setting the font name property to fixed width. Let's see if that works. You can't get the font size right. Let's see if they could get the font fixed width. Files, editor, display. Maybe I just have to choose a fixed width font, but how on earth do I choose a font? Okay, font. What are some fixed width fonts? Anonymous Pro. Bitstream Vera Sans Mono. I like this one. Is it available? Doesn't look like it. The first font that's available. Oh. No, Bitstream is not there. Anonymous, not there. Cascadia, that one's not excellent. It's okay. Cascadia. No. What are some... What is a fixed width font that's available in MATLAB? In the MATLAB editor. The fixed width setting is used to access a fixed width font. Courier New. Let's see if Courier New is available. Yes. Okay. It's light. It's a light font, but at least I now have two spaces like I expect. I don't like this font very much. What's another choice? Consolas? Let's try that. No, it's Comic Sans. Don't like it. Cochin. Don't like it. You know, some software make this name in the font so you get some idea of what it's like. You don't have to go through this sort of thing. Damascus gets cut off. That is not fixed width, is it? Nope. Dialogue. That's also not fixed width. That looks like it is. And I also don't like the font. Is that? Nope. Why is this hard? Like, console us. Looks like other people have console us available, but I do not. Add console us font to MATLAB. Install new font on Mac. Font book app or manually copy. Font book app. Font book. Okay. Select file, add fonts. File, add fonts to current user. Select the folder you want to upload. So you have to download the consoleless font. Is that the issue? Consoleless font. Install consoleless font on Mac. This is not helping us debug this code. Open Finder and navigate to the downloads directory. Is that a motorcycle? It's motored and it's a cycle, so I guess so. Okay. Double click this. Install. Is it available now? It is. It's here. Okay. Do I have to restart MATLAB? Looks like I do. I am stuck. Hey, Protost! I am stuck. Good to see you. Well, I was stuck on, Protost asks, what are you stuck on? I was stuck on some math. So then I installed a new font on my computer. Luckily, I overcame the font issue. So now I'm stuck on some math again. The issue is that I don't see a bug and it feels like everything should be working. And now MATLAB's not opening up. So that's an issue. Oh, MATLAB's not responding. Okay. See if we could open up MATLAB now. We've solved so many bugs. We've solved more bugs than we have lines of code, Protost. How's that? Oh my goodness. After all that, oh, because of course, I was being silly. Now do I have console S here? Yes. Okay, so we still don't have any code working, but at least now we have a nice fixed width font. So there's that. That's a lot of bugs. That's not an untrue statement. Yes, yes, console will make all the difference. So, Protost. Oh, there's a, like, the code doesn't even run anymore. Okay. I could change this. Maybe when I put this here, it thinks of it as a 3D array. I'm not sure why that changes anything. Could the bug possibly be in the easy part rather than the math? Of course. This is still causing issues. Now there's at least a bug that crashes. Like, that should be doable. I also moved this outside of the loop. Is that it? That can't be it. We changed the font and now nothing works. The number of data point locations should equal the number of data point values. Okay. Oh, do I need to do this? Nope. Oh. Sample mask equal 1. Data indexes find where sample mask equals 1. So I don't know if I need this. Oh yeah, of course I do. Okay. Does that solve it? The logical indices contain a true value outside the array bounds. Oh. There you go. So now we're running all this QR. we're actually getting an image out. And what's happening is the high frequency, so like the values that were estimate seem to have an origin location different than the data values that are collected. The values that we're estimating are generating this portion of the image, like this high frequency stuff, and it's shifted by half a field of view. And that will boggle your mind, let me tell you. Okay, so that tells us that we have to, the bug is clearly in LSQR. There's only two things that we're creating that go into LSQR. Apply A, B, I guess 3, and K not. We've not. Hold on. These are the values of K naught being put into the data matrix. And we see that this is making sense. And sure enough, we're doing nearest neighbor interpolation like we expect. Okay, so I believe K naught is correct now. I think that's right. Also, it shouldn't matter. K naught should theoretically be able to be anything, and LSQR should still solve the system AX equals B. And by solve the system, I mean minimize the L2 norm of AX minus B. So then the issue has to be either an apply A or B. We took a look at apply A earlier. What about B? We don't need this anymore. B has the origin in the middle. That looks like something with an origin in the middle to me. And when I do that, B is a three-dimensional array, 256 by 256 by 8. Is B correct? So we want to minimize the L2 norm of W minus I times all the K data. And the K data is this K estimate matrix plus this K collected matrix, K data. K data is this matrix. Oh! Look at this. LSQR minimizes AX minus B. And here we have, this is a times x, but then this is a positive quantity. So this is like plus the b down here. So we actually need to negate this. Protost, there was at least a problem in the easy part of the math. So there's that. Oh, it works! It works, everybody, it works! Oh my goodness. I just reread the book called Project Hail Mary, which is a brilliant book. I love that book. Yes, amazing. It's beautiful. That's a beautiful picture of an ankle. In the book, it's basically, it gives a layman an understanding of what engineering is. And in the book, he says, you just go through everything that could possibly be wrong, and then eventually you solve it. You solve one problem and then the other and then the other, and then eventually you come up with a complete solution. Okay. Okay. We have a SPIRiT recon. Let's undersample more. Man, there were a lot of issues. Oh, I forgot to actually set a breakpoint. Well, I guess. It works, it works, it works. Okay, I'm going to look at the reconstruction with the additional undersampling, just because I'm enjoying having it work. And then I'm going to check in. Let's do that now while this is running. Let's check in all this code. Protost! 2 things happened in order to get this code working. The first is we got Consola's font. But even then, we didn't get it working. It wasn't until you showed up that stuff happens. Absolutely, you helped. Well, that doesn't look good, does it? Huh. It's a lot of undersampling. Right. It's a lot of undersampling. I'm only keeping 1 out of every 3 lines. That's probably too much undersampling. But if it isn't, a larger interpolation kernel might do it. I wonder if Project Hail Mary is on my website. Reading list. I can't believe it's not here. Okay, it'll be here soon. Yeah, it's just too much undersampling for SPIRiT. It's okay. All right, we don't need any of these debug lines. So this is the we did this fixed. Now I just go through and delete all of these debug lines that I know are debug lines because I had them start in the first column of the code. They're not indented properly. Here will be an interesting test. Is warm starting helping? Let's find out. So let's make sure this code still runs after I deleted all of those debug lines. It of course should, but if it isn't tested, it's broken. Okay. There's the image that we like so much. That is a really nice image of my ankle, actually. Okay. And how many iterations did that do? 45. Now, what if we don't warm start? How many iterations is this going to take? 44. Looks like warm starting is not it's not helping anything. So there's no reason to make the code more complicated or oh my goodness. Oh no, not this again. Okay, I could do view, reset zoom. I was saying there's, okay, strange. There's no reason to absorb the computational burden or make the code more complicated if it's not actually helping anything, right? I'm always surprised when warm starting doesn't help anything. I got to be honest. Also, I ran it, right? We ran it. Let's make sure this still works, but this is getting checked in. Get oh. Yep, that's working. That's less undersampling than I wanted. Now I'm going to do undersampling the other direction. I had been doing it, well, collecting every other row of data. Now I'm going to try it with every other column of data. This issue arises. There's a little tiny bit of aliasing, isn't there? Maybe that's the limit of SPIRiT. There's this other fact that we talked about before where the undersampling pattern is related to the arrangement of coils. And if you want to understand how, then you want to take a look at this paper that my student wrote. This one, the dependence of parallel imaging with linear predictability on the undersampling pattern. So SPIRiT will work better or worse based on the arrangement of the sensing coils at the time the data was collected. And so maybe for this particular data set, and I could see why, having horizontal undersampling is better. For other data sets, I know for a fact, like if you have a birdcage coil around a knee, you're trying to take a sagittal image, I know for a fact that it only works in that case if you collect alternating columns of data. Nevertheless, we've got SPIRiT working. Last thing before I go, I already have a recon SPIRiT in the Dwark lib. I think my student wrote this. He did. And this looks like it's using regularized SPIRiT, L1 SPIRiT. Yeah, so he adapted this code from Grappa, his implementation of Grappa. And Grappa's more complicated. This also doesn't seem to have, what is the proximal operator? So it's using Fista, prox H. What is the proximal operator? Projecting onto a ball of square root epsilon. And where is epsilon? Epsilon's passed in. Oh! Wait, what? Prox H? What is grad G? What is G? What is the function G? I think G is just going to be apply G, and G is going to be the convolution. So he's solving a different problem. So G is the L2 norm of the difference between apply G to in and in. So he's solving a different problem. So his G is my W. Oh, I see what he did. Okay. He is solving the same problem as I am, but he's letting the optimization variable be all of k-space rather than just the data that was not collected. Um, and then he's doing a projection onto a ball. And this allows him to say, for those data points that were collected, it might be better if they were allowed to change to within the bound of noise. Okay, so his is better than mine, although mine is more efficient if you're not changing the data values that were collected, because I'm using LSQR rather than FISTA, and LSQR does not require a proximal step. We're going to keep this for now. We're going to leave the one in the dork lib for now. And eventually we're going to merge all of this stuff. So the next thing to do there's a few different ways to go. I can implement L1 FISTA, which is this, plus lambda times the L1 norm of psi x. Could do that. I mean, that wouldn't be L1 FISTA, it'd be L1 SPIRiT. The issue is, this is a tough one. Because here X is an image, and an image is reconstructed from the multi-coil data as using like Romer reconstruction, which I don't think is a linear transformation. Let's see, so Romer reconstruction is a linear transformation if you supply the sensitivity maps. Okay. So we could actually put Romer reconstruction here, which I've never seen done. The alternative is to make X is the reconstruction for each coils image. So this is actually like if we had 8 coils, X would be 8 different images, and then we would do group sparsity, minimize the L2 one norm. But I much prefer this. That would be more interesting. So now this is going to be K. The other thing to do is to do what my student Alex did and allow there to be a non-epsilon subject to K of sample mask equal to 1 minus K data sample mask equal to 1. This equal to epsilon. Is there even such a thing as L1 SPIRiT? Did they do SPIRiT with L1 norm? I'm sure somebody's done it at some point, but they did it like this, I'm sure. The issue with doing it like this is that the user has got to set the lambda value, and you don't know how to set lambda before you embark upon the reconstruction. So what to do? Well, you could alternatively set this as a constraint and say this must be less than or equal to some known value. And we know that value because we had been estimating it, right? We had been looking at the relative errors for each coil. So it looks like, epsilon should be something like whatever a relative error of 0.13 is when converted to an L2 norm. I'm not sure what we're going to end up doing next. Right now, this code doesn't do any of this. This is what it does. Is that what was there before? Oh, okay. This is what it does. And that's a great step forward. That's where we're going to end the stream. Protoss, always a blast when you show up, buddy. All right, everyone. See you later.